When you're sitting at a sports bar or, just in your living room watching a live game in absolutely flawless 4K, there's this expectation of perfection. Like, no lag, no drop frames, right, just a pristine picture. But you probably never think about the actual invisible plumbing making it happen.
Yeah, exactly. And today's deep dive mission is really about demystifying that exact infrastructure. We are looking at a highly technical spec sheet from HDTV Supply for a specific device. It's called the AJA Hi5-12G-R-ST. It's a $1,400 converter box that basically, well, keeps live television from falling apart.
Right, so let's look at the core problem this box actually solves, because you have these massive professional cameras transmitting what's called a 12G SDI signal, but the monitors that directors or even consumers actually look at, they only accept HDMI 2.0.
Yeah, they speak a totally different language.
Exactly. To me, it kind of sounds like trying to connect a high-pressure industrial fire hose directly to a standard kitchen faucet. Like you have to adapt that massive data pressure perfectly, or the feed just blasts the sink apart.
That is a great way to visualize the bandwidth disparity, honestly, because 12G SDI carries an immense payload. I mean, this device takes pristine 4K video at 60 frames per second, alongside massive 12-bit color data.
Wait, so how much bigger is 12-bit compared to normal TVs?
Oh, it's huge. To put that in perspective, standard 8-bit displays show millions of colors, but 12-bit workflows are calculating billions, and the AJA box processes all of that in real time to fit the HDMI protocol without, compressing the life out of the image.
Wow. And it also mentions actively generating HDR10 metadata. So if I understand this right, it's not just passively passing data along like a dumb pipe.
Right, not at all.
It's actively telling the HDMI display frame by frame exactly how bright the highlights should be and how dark the shadows should be, right?
Yeah, and generating that metadata on the fly requires serious computational power. It constantly injects the specific luminance values the display needs. That way, the colors pop exactly as the camera operator intended, matching the original broadcast spec.
Which brings us to the physical reality of moving all this data. The device has an ST fiber receiver. Some standard copper cables just can't carry a 4K signal from, say, a stadium 50-yard line all the way out to a production truck.
No, they'd lose the signal way too fast.
So we are literally shooting 4K video as pulses of light through glass cables. But if fiber uses light, how does this tiny box convert photons back into an electrical HDMI signal without lagging the live feed?
Well, it utilizes a specialized optical receiver that instantly translates those light pulses into electrical voltages.
No.
But the real mechanical magic is how it handles the signal timing. The spec sheet highlights this thing called a reclocked SDI loop out.
Reclocked. What does that mean in this context?
So when you push massive amounts of digital data over vast distances, the signal inevitably suffers from jitter. Basically, the ones and zeros start arriving slightly out of rhythm.
Ah, and if the timing is off on a digital signal, you get screen tearing or dropped frames on the broadcast.
Exactly. So the AJA box acts like a precision metronome. It receives the jittery signal, perfectly realigns the timing, literally reclocking it, and spits out a pristine, perfectly timed copy to the monitor.
While simultaneously sending another clean copy down the line for the rest of the broadcast crew, right, Raj? That completely explains why this thing runs so hot. I actually caught this very human detail buried in the product manual.
Oh yeah, the heat warning.
Yeah. This little convection-cooled unit constantly draws 11 watts and gets very warm to the touch.
Yeah.
The manual explicitly warns users not to stack them on top of each other.
I mean, it is doing an enormous amount of continuous real-time math in a tiny footprint. And in a live broadcast environment where you cannot have dead air, you need what essentially amounts to engineered paranoia.
Engineered paranoia, I like that.
Yeah, for instance, there's the video source auto switchover feature.
Yeah.
It monitors both the primary optical line and a backup SDI line. So if a cameraman trips over a fiber cable and snaps it.
Which definitely happens.
Oh, all the time. But the box detects the voltage drop and swaps to the backup feed in a fraction of a second. The viewer at home never sees a single glitch.
So it really is this complex, intensely hot-running fiber optic translator just working tirelessly in the background to ensure you never even notice it's there.
It is the invisible bridge of modern viewing, truly.
It really is. So as consumer expectations inevitably push beyond 4K and into 8K, multiplying this data load all over again, how will the physical limits of heat, cable bandwidth, and distance force this hidden infrastructure to evolve next?